All right, welcome everyone to Advanced Assembly. Mark voids a warranty. This is my favorite part of the job. I basically get to take things apart. Fortunately, it's usually things that I used to love, but what are you going to do? Besides, it's useful from time to time to take old circuit boards, hit them with the hammer, and then nail them up on your wall and leave them there as an example to all the other devices that you have that might want to misbehave. Just what might happen to them. Yeah, these things, they get brave, they get bold, they just want to start doing their own thing, and we can't have that. No. Now, the issue with this particular device that we're dealing with today, it's a little mini computer, and it stopped, basically something inside has stopped working, so that whenever the power is off, whenever it goes to sleep, it can't keep time anymore. Usually the way that works is one of these integrated circuits has a real-time clock in it that just keeps ticking away at very low power, as long as it's hooked up to a battery. And what happens from time to time is that the battery dies. It's not really anything that you need to, well, this wasn't built well, blah, blah, blah. No, batteries die. How long, that's usually not the people that make these aren't usually the people that make the batteries. So with that, we're going to take it apart, look inside, and see what we can learn. A lot of times, device manufacturers like to hide their screws underneath feet. So that's always a good spot to start looking. And you can see right down in the hole, we've got what's called a telecentric lens overhead that allows us to look at things with no deflection at all. And you can see little Phillips screws in there. I'm just going to pop those out. If you ever have a screw that doesn't want to come out of the hole after you've loosened it, you can always take a little bitty magnet to it and pop it. See, there we go. That's kind of fun. Let's get, I think we've already loosened those. We just need to grab them with the magnet. Come on, little guy. Come on. Come on, little guy. There we go. All you need is a little bait and time. Come on. I think I might just have to flip this and give it a little whack. Number 3. Come on, number 4. Nope. Okay. So there are our 4K screws. And this thing then should hopefully pop open. Come on. There we go. Let's see what we have in here. Feels heavy. Ah. My favorite thing to find in any electronic device of quality. A value-added mass. So what these people have done is to make their device heavier, I'm sure to keep it from sliding off a desk, they have dropped a big piece of galvanized steel right in the middle of this thing. Really, usually all the people try to do with stuff like this is just make their devices heavier. They're not fooling anybody. We're going to take that and set it off to the side. Value-added masses. You'll see that too sometimes. I've seen people online scammed. They buy a external hard drive, and the hard drive is a little USB thumb drive or an SD card with, a couple washers in it for weight, so it's quality. Anyhow, so here we are. Just going to pop this stuff out. Looks like we've got a couple screws, and then we'll know a little more about what we're dealing with here. You probably have a better view of the screws than I do from the overhead cam. All right, there's one board. Let's go ahead and get those mounting screws. Should be one more. It's stuck in there. Here is our offending battery that is likely causing us so very many issues. And we've got a secondary board. One more. So probably all that's needed to get this computer back into tip-top shape again is just replacing this little coin cell. So I'll have to look for one of those later. It looks like it's got a little JST connector on the end there, maybe a 1.27 millimeter pitch. I'll have to actually pull out some tools and record that in a little bit, but we'll see. All right, let's look a little closer at this bad boy. So this first circuit board has a zero insertion force connector on it that connects with a flat flexible cable to the rest of the device there. Just kind of getting a feel for what's going on front and back, and then we'll talk about it a little. Interesting. Okay, so first things that we have, we've got the VGA, which is a D sub mini 15 pin connector. That one likely feeds this particular integrated circuit here, which leaves the USB for that one. Except where are the traces? Don't know. Need a little better lighting to tell, or a microscope. But we don't have microscope on the cameras just yet. Oh, we do have something cool though. This is kind of new. If I hit the button that says key 2, I mean that is of course if I find the button that says key 2, I can do a neat little trick. There it is. Logos. Fun, huh? All right. So looking, I'll tell you the first thing that stood out to me when looking at this, and that is that they ran their copper right to the edge of the board. That's usually not a best practice. You want to keep the copper pulled back from the edge a good, 12 to 14 mils. It gives you better lamination strength, less chances of short circuits during the route out process. So I don't really know why they ran that to the edge on this side. They obviously pulled it back on the rest of it. So I don't know what the design decision there was. That is interesting though. Sometimes you'll run it to the edge if you're going to plate the edges. They've not done that here. For signal integrity concerns, electromagnetic compliance, that sort of thing. All right, so the next thing that I'm noticing are this set of vias right down here. And I'm looking at these guys. So it's got a set of 12 vias. This is a very small pad, and they are connected to the thermal pad underneath this integrated circuit. Usually designers will do this to help dissipate heat between the layers. But I don't know that you necessarily need that many. Texas Instruments put out an apt note a few years back, I don't remember how many, where they actually analyzed this. They went from 1 to, whatever number, 16, 25. And they found out that there's a diminishing returns after you hit around 8 or 9 of them. So that might be a few too many vias for this particular area. That's actually backed up too by Dr. Brooks. What was his first name? And Adams. Douglas Brooke and Johannes Adams recently put out a book on printed circuit board trace temperatures, with diameter, and it also included an analysis of vias. And they found something interesting, that the via temperature depended on the temperature of the traces that surrounded it. Not really much else. It didn't really depend on the current traveling through it or on the size of the via. It just depends on the surrounding copper. So they do a good job of transferring energy, or good enough. But I don't know that you need that many. I would have to look up, the latest IPC standard to confirm or deny that. I want to say IPC 7351 has some information on that, but I don't know off the top of my head. I'm happy I know as much as I do off the top of my head. I don't need more. Then, as you look around, you can see that the designers did quite a few vias where they stitched from point to point to point to point to point. And that helps prevent these copper pores from turning into unintentional radiators. As you connect the different layers, you don't end up with antennas. Then we've got, this is the power switch. This is the LED, the light on LED. So, interesting. Something else this does that's fun is picture in picture. I know, this is a fancy little toy. Let's see if we can get that to turn on for you. Oh, it's 2 pictures of me. That's too much, Mark. Let's try this. Nope, wrong one. Okay, I might have to actually read the manual. Let's try it one more time, and if not, we'll just get going. Nope, wrong one. Okay, well, I'll read that for next time for you. Let's keep looking. Next up, we've got the rest of the printed circuit board. Looks like a nice little board. Enig around all of the exposed features. You've got quite a few test points in here. The nice thing is the test points are all on one side. That's great, because usually what happens is you'll take a board like this and you'll put it into a fixture, and those things will either have 3mm or maybe 1/8" holes, and they'll be on diagonals. And those help to locate this in a fixture, and then this whole thing gets pushed down, and little spring-loaded pins hit it from below, and those spring-loaded pins do whatever tests that you need. Boundary scan tests, maybe they're just doing some JTAG stuff. It just depends on how that thing's done. The minimum spacing that you want for fixture or for test pins is about 50 mil, 1.27 millimeter. These things are pretty close. They're pretty tight. I would have liked to have seen those spread out a little. You can't always do that, by the way. Another reason that you want those things spread out is it can concentrate quite a bit of force into a single area of your board. Each of those test pins is, nominally 1 Newton meter for the, 1 Newton per test pin, 1 Newton per probe. So you've got, a few of these into this really small area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21. Okay, so just in this little area, you've got, 20 newtons of force. That's not nothing. I'm sure this device can handle it, but that can be enough stress to, damage an IC, maybe crack a solder joint for some smaller components. I don't think that's the case here. I think that this is going to be well supported on the other side, especially with that big old heatsink and whatever downforce they have, but it's just usually a best practice to space those out a little. Little 4-pin, I'm guessing some UART debugging. We'll see what else we have here. A random switch. Wonder what they do with that. Maybe that enters a bootloader mode or something. I don't know. All right, let's keep looking. So we've got what appears to be just the RJ45 jack with non-integrated magnetics. That is what I would assume to be the magnetics, but that's a little bigger than, and a few too many. Well, I guess it could have a lot of grounds. If that is an integrated mag jack, that is the smallest one I've ever seen. That can't be integrated. That's got to be it. But to save space, to save board height, they actually cut this thing into the board. Something you don't see all that frequently, but I guess for low profile devices, every little bit helps. You can make out a few other things. They still used that power pad trick where, you put the vias and use that to draw the heat down out of the component and then let it start spread in the rest of the board. We've got the RF module. This is the Wi-Fi for the board. It's encapsulated to keep any stray RF emissions in. And then that leads out to our antenna. There's a couple really tiny capacitors and resistors there. Probably 021s, maybe 0402 on those, and then the other ones are 0201s, but those things are tiny. Those just, you get a little pi network or something going to balance the antenna. Okay, and then on the front side, everything looks good. I mean, they did a lot of things that I really like. You've got copper poured everywhere. That's great for thermal characteristics. It helps keep your board from turning into a potato chip during reflow. Really handy stuff. I've got no complaints about anything that I'm seeing here. Everything's nice and clean, and with any luck, all we'll have to do is just replace that battery, and this guy can go back together and live to annoy me another day. Well, we'll have to find something else to tape up on the wall and destroy. All right. Well, I hope that you enjoyed the first live version of Mark Voids a Warranty, where I was smart enough to turn the microphone on. Yeah, in previous edition, well, I guess the inaugural edition of Mark Voids a Warranty, people didn't hear anything. It was sad. I was talking to no one and no one heard me. And they didn't have anything to say. And then in the one before that, the dry run through, I did on a private channel. That wasn't on Advanced Assembly Circuit. So with that, I'm Mark. If you ever have questions, if you ever need anything, Advanced Assembly is always here to help. Just reach out to sales@aapcb.com and they will direct you to the right party. Whether you're looking for research and development or you want to get a hold of me, whoever you want to get a hold of, just reach out to sales. We don't really have a front office secretary answering the phones, but sales, they take care of all that. And we try to take care of you. The thing that we usually say is we'll make your first job with us, we'll make the price so good you won't be able to say no. It's not a mafia threat. We just really cut the price. So All right, everyone. We'll see you next time on Mark Voids a Warranty. And if I can find something to take apart, that next time's going to happen in about 5 minutes.